Here in this video, we are solving two simple problems on capacitors. Let's look at the first problem. This is of NEET 2021. The equivalent capacitance of the diagram is, see, here a wire is connected to this capacitor across. So at this point, if we are having a voltage V, as it is connected to the same wire, here also there will be a potential V. As the same wire come across to this point, here also there is a potential V. Means what? Across this third capacitor, there is no potential difference. At both ends there is the same potential. As there is no potential difference, it won't store any charge in it. So though it is physically there, it's like a dead element in the circuit. Dead element. So you can just ignore that part. So what will be the remaining is the upper capacitor C and the lower capacitor C. That is physically there, but that doesn't store any charge. So obviously that these two capacitors are in series, are in parallel. As they are in parallel, C resultant is C1 plus C2, that is 2C. So answer for that problem is 2C. That's how we solve that problem. It's a simple problem. You need to know this concept that whenever it is connected to the same wire, the potential generated at any point of that wire will be the same V itself. It's a simple concept, right? Let us solve the next problem that is given in NEET 2021. This is also a problem on capacitors. It says that a parallel plate capacitor has a uniform electric field E, and the space D is the space between them. If the distance between the plates is D, area of each plate is A, energy stored in each capacitor is how much? Stored in that capacitor is how much? We know energy stored in a capacitor is half CV square. But our answer is not in this format. So I have to write C in terms of epsilon naught. What is that? We know for a parallel plate capacitor, whose area of cross section is A, distance between the plates is D, and if vacuum is there between them, the permittivity is permittivity of free space epsilon naught, and the capacity of a capacitor C is epsilon naught A by D. So as C is not there and epsilon not there in the options, in the place of C I have to write this epsilon naught A by D. Not only that, there is electric field intensity term in the options. Potential is not there. So I shall know the relation between potential and electric field intensity. What is that relation I can say now? We know generally electric potential can be written like 1 by 4 pi epsilon naught Q by R. Electric field intensity can be written like 1 by 4 pi epsilon naught Q by R square. So I can rewrite electric field intensity as 1 by 4 pi epsilon naught Q by R square as 1 by R and 1 by R. In the place of 1 by 4 pi epsilon naught Q by R, I can write electric potential. So E equal to V and by 1 by R. That implies V equal to ER. Here the distance between the plates is D. So V can be written like ED. So in the place of this V, I have to write this potential formula. In the place of C, I have to write this capacitance formula. Then I will get the new format of energy stored in a capacitor. That implies energy stored in a capacitor is half CV square. So in the place of C, epsilon naught A by D. In the place of V, ED whole square. So what will be this formula is half epsilon naught A by D, electric field intensity square and D square. 1D gets cancelled. So the answer is half epsilon naught A E square and D. That is the electric energy stored between the plates of the capacitor. Look at the options now. This option half is there, epsilon naught is there, E square is there, A is there, and D is also there. So option C is the right answer to solve this problem. So both are simple problems, that's why I have just combined them together. Therefore you will be quickly learning both the problems. Both are given in NEET 2020 and 2021. Of course the concepts are both are different concepts of the same capacitor, right? That's how we solve both these problems. Thank you for watching.